Number 18. This is one of those probability questions involving the normal distribution and a range of values. So they tell us the mean lifetime of this kind of copy machine is 53.1, so that would be mu, and they tell us the standard deviation is 7.5, so that would be sigma. And then they ask for the probability that the lifetime of an individual copy machine will be between 51.5 and 54.5. I can write that like this: the probability of X being between 51.5 and 54.5. The first thing we do is we take each of those numbers and find the z-score using the formula x minus mu over sigma. So for example, the z-score for 51.5 is parenthesis 51.5 minus, remember the mean was 53.1, close parentheses, divided by, and then we have sigma, which was 7.5. And that came out to be negative 0.21333, but these z's, we want to round them to 2 places after the decimal point. So it's about negative 0.21. When you do the same thing with 54.5, you get a z-score of positive 0.186 and so on. And if I round that to 2 places after the decimal point, it's 0.19, a 9 because of the 6 after it. So now this is the probability of z being between negative 0.21 and positive 0.19. So I have to look both of those z-scores up on table E. Now remember what that looks like. Here's table E. To look up negative 0.21, I go to the page where the z's are negative, and I go down to negative 0.2, and you can't see it, but at the top of this column there's a 0.00 and a 0.01, and that's the one I want. So for negative 0.21, it's this number right here, 0.4168. Then for positive 0.19, here's where z is positive 0.1 and go all the way across to the 9, and the number there is 0.5753. Then the last thing I have to do is subtract. Take the bigger probability minus the smaller for my final answer. 0.5753 minus 0.4168 equals 0.1585. For what positive value of z is the area under the standard normal curve to the right of that z equal to 0.1611? So I'm trying to figure out, what does z have to be? Where along the z-axis would I be? It would be somewhere in this half, because it does say a positive z value, but there's some z over here greater than 0 where the area under this bell-shaped curve to the right of that z, the part I've got shaded in red here, is equal to 0.1611. That is about 16% of the whole thing. So to figure that out, first I have to subtract 1 minus 0.1611 to find how much area is over here to the left of z, because that's what's on table E. Table E is about the area to the left of z. So 1 minus 0.1611 is 0.8389. Now I turn to table E, and I look for that number, 0.8389, and here it is, and it goes with a z-value of 0.99. So that is the z-value. It is positive. That's the answer. Oh, while we were on number 18, I meant to mention that the way I did it was using the table, but it is also possible to do this on a graphing calculator. So here's how that would work. I would go to the distributions menu, select normal CDF, and I've already done part A, so let me do part B. For less than 51.5 months, that means everywhere from like negative infinity or as far down as you want to go up to 51.5. So my lower limit should be some really negative number. And I can just go ahead and use what it gave me, or I can put in something like negative 99999 or something like that. My upper limit on this one is 51.5. My mu is 53.1, and my sigma is 7.5. So when I paste that in, it looks like this. Hit enter, and it gives me an answer of 0.4155. That's not exactly the same as you get on the table, because doing it the table way involves rounding the z, and you get a little bit of round off error, but it's really close. And so I would accept either one of these answers. For number 20, here we want the cutoff score for the bottom 10%. So we do this by first finding the z that separates that bottom 10% from the rest, the upper 90%. So if you look in table E, for the closest area you can find to 10%, right here I see 0.1003. That's real close to 0.10 exactly. And that goes with a z-value of negative 1.28. So with that z, we plug that into the formula x equals z times sigma plus mu. So we take negative 1.8 times the standard deviation 17.2 plus the mean 123.0, and we get 101. You could also do this on a graphing calculator with the inv-norm function. You need to give it the area to the left of or below the cutoff score. Here that is 10% or 0.10. And you need to tell it the mean, which was 123.0. And you need to tell it the standard deviation, which is 17.2. And it gave me an answer of 100.95 something, so about 101. Number 21. A researcher is interested in estimating the average salary of elephant trainers. How large a sample is needed? So this is a question about sample size for the mean. How big the sample has to be if you're estimating a mean or an average. The formula for that looks like this. N equals z sub alpha over 2 times sigma over e, and then the whole thing is squared. The z sub alpha over 2 depends on your confidence level. For 95%, it would be 1.96. The sigma is the standard deviation. We are told that that is 1,130. And the E is the margin of error, or the maximum error of the estimate. You want your estimate to be within $500, so that's what we're putting in for E. So we calculate this, and it comes out to 19.62 something, but sample size has to be a whole number. You can't have fractional elephant trainers. And for sample size, we always round up to make sure we have a big enough sample. So here, rounding up gives us the number 20. Number 22 asks for a confidence interval for a mean. And notice that it says it's a group of 15 students, so it gives us how many are in the group. That's the sample size. It gives us the mean for that group, so that's the sample mean, that's X bar. And it gives us the sample standard deviation, 5. Now, since that is a sample standard deviation, we are doing a t interval, not a z interval. The formula for a t confidence interval for a mean looks like this. We have to get the t sub alpha over 2 values from table F. Degrees of freedom is 14 because it's sample size minus 1. And when you look on the table F, for a 99% confidence interval and 14 degrees of freedom, the number there is 2.977. So that is what we would be using for our t sub alpha over 2. So with everything put into the formula, 97 minus to 97 plus 2.977 times 5 over the square root of 15. I did say to round your answers to the nearest whole number, so it came out to be about 93 to 101. It is also possible to do this using the t interval function of a graphing calculator. We have to put it on stats and put in the numbers for X bar and S and N and our confidence level. So here X bar was the sample mean 97, S was the sample standard deviation 5, N was the sample size 15, and our confidence level was 0.99. So we got 93.157 to 100.84. So rounded to the nearest whole number, that is 93 to 101. Number 23 asks for a confidence interval for a proportion. So make sure you use the formula for a confidence interval for a proportion. In this formula, p hat is the sample proportion. And here, that would be 66%. 99 out of 150 is 0.66. So we put in 0.66 everywhere the formula has a p hat. And then the q hat is 1 minus 0.66 or 0.34. And when I did this, I put in 1.645 for the z sub alpha over 2, but you might use 1.65. I just used one more decimal place. So if you round your answer to the nearest whole percent or nearest 0.01, 2 digits after the decimal point, it comes out to be 0.60 to 0.72. So it's somewhere between 60 and 72%.